Okay, guys, this time we're going to talk about the square root method and just a little bit of background before we get into the square root method. Um, Remember that if you are going to take the square root of a number, it's going to have two answers, because not only does 5 times 5 equal 25, so does negative 5 times negative 5 also makes a positive 25, right? There is no real number that's going to be negative under there. So plus or minus 5, positive 5 and negative 5, two solutions every time, right? All right, then the other thing, until we look at those complex numbers, but when we're just under general, there is no such thing as a negative under the radical, right? It has to be greater than, let's see, let me write it this way. X must be greater than or equal to 0. In other words, it must be positive, right? In 1-3, we'll talk about complex numbers, but that's a different situation. In general, we're always going to expect that what's up under here is always a positive number. All right, so the square root method is just take the square root of both sides. Let's say that I have x squared minus 4 equals 0. Well, both of those are squares, right? If I add this 4 to both sides, then I've got x squared equals 4. And I'm going to take the square root. So that's going to be x, and the square root is going to be plus or minus 2. Okay, every time. So square root method, if you recognize that you have those two squares, then you know you're going to have just, what if you have x minus 4 squared is equal to 81? All right, same thing. Square root of both sides. X minus 4, because these two guys, this square and this radical, cancel each other out. That's a plus and minus. That's a multiplying and dividing. They cancel each other out. All I'm left with is the x minus 4 equals plus or minus 9. Okay? Then I got to add the 4 to both sides. So x is equal to 9 plus 4. X is equal to negative 9 plus 4, because it's plus or minus 9. So I get 13 or negative 5 for a solution set. Okay. One more of these. What if I have 2x plus 8 quantity squared equals 64, right? Or let's make it, you know what, let's take it out of being, well, we'll do it too both ways. So again, square root from both sides. These two cancel each other out, and I'm left with 2x plus 8 equals plus or minus 8, right? So then I got to subtract that 8 from both sides. And 2x equals plus or minus 8 minus 8, and divide by 2. All right, so I have 8 minus 8 divided by 2, and that's going to be 0, right? Because 8 minus 8 is 0, and 0 divided by 2 is 8. Then I have negative 8 minus 8 divided by 2, and that's going to be negative 16 divided by 2, so that is negative 8. My solution set, 0 and negative 8. What if it doesn't come out with a perfect square? And I'm going to use this one again. I'm going to say 2x plus 8 squared, and we'll say trying to think of one that has a square in it. We'll say 12. Okay, 12 is not a square number. We're going to take that square root of both sides, and we're going to have 2x plus 8 equals plus or minus, and we're just going to leave it up under the radical. Okay, and then it's going to be the same thing. We're going to subtract that 8 and divide that 2. So I have the square root of 12 minus 8 divided by 2. I have the negative square root of 12 minus 8 divided by 2. Now that can definitely be simplified. First off, what about the square root of 12? Square root of 12 can be broken down to the square root of 4 times the square root of 3, right? So that's going to be 2 times the square root of 3. So 2 times the square root of 3 minus 8 divided by 2. Look at all 3. If it would just be 2, you cannot go any farther. But because I have all 3 of them can be reduced by the 2, then I can do that. And I'm going to say the square root of 3 minus 4. Okay? Same thing here. Negative 2 times the square root of 3 minus 8 divided by 2. All 3 can be reduced by the same number. So that's a 1, that's a 4, that's a 1, and I just get left with negative 3 square root of 3 minus 4. These are my 2 solution sets. Okay? All right. Square root method. Just take the square root of both sides.